So first level questions are how many valence electrons does an atom have? Next level question would be how many electrons does an ion have? I want you to be able to work through those sorts of questions. Now, clear all my drawings because whenever we're drawing a Lewis structure of a molecule, we've got to know the number of valence electrons. And so the more comfortable you are with a table like this, the more comfortable you're going to be as we go through the process of drawing a Lewis structure or predicting Lewis structure. So our first question of the day, how many valence electrons does hydrogen have? Okay, about 15 seconds left. What do we got? Correct answers. Wonderful. This would be like a lower tier question, but perfect, or not lower tier, like base question. Wonderful. Okay. Next up, same sort of question, familiarity with the periodic table. And this is a good one to kind of keep in mind because fluorine is our most electronegative element. It's helpful to just kind of be ready with the recall of how many valence electrons fluorine has. About 30 seconds left. 10 seconds. Right. Correct answers. Wonderful. Fluorine is 7. Now, if I had said fluoride, that would be an ion of fluorine, and that would be a total of 8. Now, we'll come back to this one because what I want to do is I want to go through the process of drawing a molecule. So keep this in mind as like, what are the steps? Like you want to, if it's almost like a recipe. You're building something. In this case, we're building a molecule. So the first thing that you need to do is look at the formula for that molecule. And then once you have the formula for that molecule and you have all of the atoms, and basically you have to look at the periodic table and become familiar with how many electrons, how many valence electrons they bring in. Okay, so let's go ahead and use CH4 as our model. Carbon brings in 4 valence electrons. Hydrogen, a single hydrogen brings in 1 valence electron. You guys already went through that. Now, there are 4 hydrogens, so that means we've got 4 times 1 or 4 valence electrons. So 4 plus 4 is 8 electrons. So we've got 8 electrons to draw. So after you have all of the atoms and all of their electrons, find our central atom. Now, there's kind of a pattern that you follow, and that pattern is the farthest to the left on the periodic table except hydrogen. Okay, so we've got two atoms, carbon and hydrogen. Since we're not going to use hydrogen as our central atom, we're left with only one atom, and that's carbon. So we're going to put carbon at the center of this. Once you have that, then draw all other atoms around that central atom. H, 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 H. Okay? Connect each one of these with a line. How many electrons, add to the chat, how many electrons does that single line represent? 2. Perfect. Okay, so based on that, how many electrons have I drawn in this molecule right here? I've got a couple votes for 8. So each one of these lines is 2 electrons. So here's 2. I'm gonna put a star so I don't put a confusing dot. There's 4, 6, 8. So we got 8 electrons surrounding that. How many electrons did I have to draw available to me? I had 8. So I basically combined the valence electrons that carbon brings in and the valence electrons that hydrogen brings in, and that's where I arrive at 8 total electrons. I can use my eraser, get rid of this. And then I'm going to draw my lines back in. Boom, boom. There is the Lewis structure of CH4. Now, this is I would argue this is again kind of that first tier. CH4 is kind of a first tier molecule because you've got a bunch of hydrogens. Hydrogen only wants to have 2 electrons around it. And then carbon wants to have 8 electrons around it. If we look at this, hydrogen has 2 electrons. Hydrogen has 2 electrons, 2 electrons, and 2 electrons. Now, if we look at carbon, carbon is sharing these electrons. So here's 2, 4, 6, 8. So it's sharing all of those electrons. So basically, each atom here has a satisfied octet. It has the exact number of electrons that it wants and it needs. Now, if we look at what we're going to do here is just look at a couple of different molecules. We look at H2O. We've got 2 electrons from hydrogen total. Two hydrogens, 2 electrons total. How many valence electrons does oxygen bring in? Or how many valence electrons does oxygen have? Let me rephrase it that way. 6. 2 plus 6, 8. We've got 8 electrons to draw. Okay. Now, what I want to do is I want to draw this molecule, putting a central atom that is not hydrogen. So then again, I'm left with only oxygen as my central atom. So there's my oxygen. Now, in either direction of that oxygen, I've got a hydrogen or a hydrogen. So of my 8 electrons that I could possibly draw, how many are displayed in this structure right here? I've only got 4. That's absolutely right. Okay. What does that mean? That means that I have 4 left to draw. Now, there might be, let's say if I do this. Now, we've looked at water before, and we know that that's not the structure, but why does this structure right here present a problem? You can either say it aloud or add it to the chat. Caitlin, you're absolutely right. It has too many electrons. Hydrogen has too many electrons. Hydrogen only wants to see 2, and in this model, I've got it having 4. So what do? Well, the alternative is I do what's called a lone pair. We've talked about lone pairs a little bit, but here is our lone pair of electrons. Now, typically when we draw water, we draw it with this structure. And that's because those lone pairs of electrons occupy way too much space. Now, in this structure right here, how many electrons are surrounding oxygen? Two, two more, two more, two more. So I've got 8 electrons. So this is my structure for water. Does every atom here have a satisfied octet? It does. All of these atoms are good. Now, next up, NH3. Okay. Again, we've got hydrogen. I always like to just do the mental math and I say, okay, well, each hydrogen is bringing 1 electron, so I've got 3 electrons there. How many valence electrons does nitrogen bring in? 5. Now, again, I've got nitrogen or some atom and hydrogen. I need to figure out which one of my atoms is my central atom. Nitrogen or hydrogen? Well, it can't be hydrogen, so I'm left with nitrogen. Then I draw basically this bare bones structure. Am I done? And if I'm not done, then what can I do to make this a good structure? We kind of know some boundaries. Hydrogen, as far as hydrogen is concerned, are we done? Yeah, hydrogen wants to have 2 electrons. Each one of those hydrogens is like, I'm good. You got me everything that I needed. I needed 2 electrons. I've got 2 electrons. Kaylee, that's absolutely right. Add 2 dots above the nitrogen. Now, if hydrogen, if I need to make the hydrogens happy, done. I was done with that earlier. Nitrogen, with this lone pair of electrons, this is also good because here's 2, 2, 2, and 2. So 8 electrons there. So this is what NH3 looks like, where we've got a lone pair of electrons. Does anyone have any questions about that? Now, we've kind of seen something like that before because we've talked about nitrogen and what nitrogen likes to have. It likes to have a lone pair of electrons. It brings in 5 of its own valence electrons, and when you give it 3 bonds, it's kind of happy. Now, we've got 3 more molecules that we're going to look at. Oopsies. Okay, so next up is SF4. This is sulfur tetrafluoride. Okay, now this is going to ramp things up a little bit. How many valence electrons does sulfur like to have? To answer this, we can go back a little bit. Oh, not there. Instead, I wanted to go to my valence electrons. Sulfur rolls in with 6. Absolutely, you're right. What about fluorine? Because it's SF6 or SF4, sorry. Fluorine's bringing in 7. Okay. So we've got 6 and then 4, 7 each. So we got 28 electrons. Okay. So before we do this, I want you to know that there are some elements, some atoms that can exceed the octet. There are some that can take on more than 8 electrons, and then there are others that don't need as many as 8 electrons surrounding them. Knowing this is going to be very helpful when we draw the structure. So 6 plus 28, we got 34 electrons. Between these two elements, sulfur is farthest to the left on the periodic table. Then we've got F, 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 F. We'll start out with that. Draw a single line. Based on this, we've got 2, 2, 2, and 2. So that's 8 electrons. So now we're down to 34 minus 8, 26 electrons left to draw. I'm going to erase my 2's just because otherwise it's going to be kind of hairy in there. The next thing that we're going to do is we're trying to complete the octets. You know, right now, does sulfur have a complete octet? Does it have 8 electrons around it? It does. So if sulfur is happy, we don't need to really do anything with sulfur at this point in time. What we can do, however, is try to make the fluorines happy. So the way that we're going to do that is complete their octets. I always like to start on the left-hand side. 1, 2, 3, 4, 5, 6. And I'm going to subtract along the way. So 26 minus 6 is 20. And I'm going to say those 6 electrons are those 6 electrons. The next thing I'm going to do is go to this bottom one. 2, 4, and 6. So minus 6 equals 14. So I'm going to point out these electrons are those. Then I'm going to bring my math over here. 14. I'm going to go to this fluorine on the right-hand side. 1, 2, 3, 4, 5, 6. 14 minus 6 is 8. And I think everyone can kind of see what's happening right now. I go to that top fluorine, 1, 2, 3, 4, 5, 6. Minus 6 is 2. So that's 6 more electrons there. We've got 2 left. Do all the fluorines have a complete octet? They do. Does sulfur have an octet? It does. When you get to a point like this where you have an excess of electrons, what you're going to do is put them on your central atom. So what you're going to end up with is something like that. SF4, there is our sulfur exceeding its octet. So sulfur can exceed the octet. Now, if you're watching this and you're thinking about this, I want you to be thinking about like exam type questions. One exam question, like I mentioned previously, would be like that basic tier. How many valence electrons does an element have or does an atom have? Okay. The next level of that would be how many electrons does a specific molecule have? And then the third and highest tier would basically be how many total electrons are on this, or how many lone pairs of electrons are on this element in this molecule. So when we look at this right here, I could ask the question, how many lone pairs of electrons are on fluorine? And you have to process that information, process that question. How many lone pairs? Well, a lone pair is 2 electrons. So how many lone pairs are on each fluorine in this molecule? Answer that in the chat. 3, absolutely. Okay, now another question would be, how many lone pairs of electrons are on sulfur? Just 1. That's absolutely right. This is one place where people have a tendency to get kind of mixed up. Like lone pair, if I tell you that I have a, you know, a pair of Oreos. You know that I'm talking about having two Oreos. But sometimes people will look at a lone pair of electrons and say, oh, well, that's one lone pair. Yes, this is one lone pair. But how many electrons are in a lone pair? Two. So make sure that you don't get tripped up on that sort of question. What we went through, absolutely. So the questions, I'll kind of write them out. How many? I'm going to label it as LPs on fluorine. I'm going to switch colors to, to show my answers. Here's one lone pair. Here's another lone pair. Here's another lone pair. Now, what I'm going to do also is I'm going to switch to, let's go with a green. And I'm going to circle this. I've circled two electrons. Are they a lone pair? No, they're a shared pair, also known as a bonded pair of electrons. These electrons that I circled in green are shared between fluorine and sulfur. So they are not a lone pair of electrons. Okay, so then to go back to my original question, how many lone pairs of electrons on fluorine? That would be three. Then to go to red, how many LPs on sulfur? The answer to that question would be one. So make sure that you can identify a lone pair of electrons. Okay. Does that make sense? Okay, great. So now what I'm going to do is go on and we will do, let's see, let's go back. I'll clear my drawings here. CL, oopsies. This should be ClF3. Okay. Let's see if this molecule has any lone pairs of electrons. ClF3. Okay. Chlorine trifluoride. The key is that this is tri because there's three. Now, how many electrons? I'm going to scribble this out because this should not be capitalized. It should be lowercase. How many electrons does chlorine bring to the table? And then how many does fluorine? Yes, absolutely. Chlorine brings 7 of its own. Then each fluorine brings 7. So that means we got 21. So we got a total of 28 electrons. Now, between these two, this is kind of complicated. Whenever you have something like in this case, we've got 3 fluorines. When you have one element where there's only one of them, like Cl, and then you have another element where there's 3 of them, I think that it's pretty safe to say, okay, well, if there's multiple fluorines, those are going to be kind of on the outside. Okay. Now we've got 28 electrons to draw. I'm going to draw these following our rules. We got 2, 4, 6. So minus 6, because we wanted to put together our bare bone structure. Now we've got 22 electrons to draw. The next thing that we're going to do is we're going to, right now what I can see is chlorine does not have a complete octet. Fluorine, none of those have complete octets. Before I put a lone pair of electrons on chlorine, I'm going to go through and take care of each one of those fluorines. So I'm going to say here's 2, 3, 4, 5, 6. So 22 minus 6 is 16. Now, my next fluorine, 1, 2, 3, 4, 5, 6. Minus 6 equals 10. My last fluorine, 1, 2, 3, 4, 5, 6. Minus 6 equals 4. So now I'm down to 4 basically excess electrons. Okay. Chlorine doesn't have a complete octet. I knew that earlier. So I'm going to put 2 electrons there. So I'm going to say -2. I've got 2 left. My other 2 lone pairs of electrons, or those other 2 electrons, that one lone pair of electrons ends up on chlorine as well. I'm not going to do any sort of double bonds or anything bonkers like that, but this shows me everything that I need to see. I've got chlorine with 2 lone pairs of electrons, and then fluorine, 3 fluorines, each with a single bond and 3 lone pairs of electrons. Now, what's important to note is that chlorine exceeds the octet. So again, thinking about different tiers of questions that I could present to you on an exam. Like a 3rd tier question would be something like, which element, I'll say element or atom, exceeds the octet in ClF3? What's everyone's answer to that question? Chlorine. It's chlorine because fluorine has 8 electrons around it, or it sees 8 electrons. Fluorine is sharing 2 of them right here. And then it's got 1, 2, and 3 lone pairs of electrons. Chlorine, on the other hand, has, that's not what I'm looking for, that's what I'm looking for. Chlorine has these 2 electrons, these other 2 electrons, and then it's sharing these, these. So there's this question, and then how many electrons does Cl have, I'll say, in ClF3? And if it, in that question, before anyone answers this question, it's sharing electrons that it shares, it has. So lone pairs of electrons and shared or bonded pairs of electrons are used for this count. So considering that, how many electrons does chlorine have in ClF3? That's right, it's 10. You have to account for all of those total electrons. Okay. I think what I'm going to do is stop right here because we've gone through, let's see, that's 4 examples. Well, technically 5. We'll do one more example to kick things off on Wednesday. One more example of a element with lone pairs of electrons on a central atom. And then what we're going to talk about is kind of a simpler range where we talk about elements that do not have any lone pairs of electrons on that central atom. So what I want you to take away from this is basically work through the process of drawing a molecule. How many lone pairs of electrons does it have? How many total valence electrons does it have? How many total electrons are there to draw? Once I have the total number of electrons to draw, then I put my bare bones structure together. I try to put together a molecule. Now, with that said, you'll have scratch paper on your exam. So whenever I ask questions like those that are presented here, it's good to have scratch paper so you can work through that process. Other than that, though, I'm going to go ahead and stop my recording.